Welcome to AP Calculus. We're going to start by doing a little bit of an algebra review. We'll include in that some pre-calculus review in a little while, a couple days, and then after that we'll finish this first part of the review up with some exponents and logs. So let's get started with the algebra review. First of all, let's talk about absolute value. We are interested in some kind of nonsense statements, and one of the ones we work with are absolute value expressions. These nonsense expressions we use to represent solution sets, and we do this in this first unit so that you can learn how to represent solution sets in calculus. So first of all, if you had something like the absolute value of A is equal to B, that means that A equals B or A equals negative B. One of the two. If you had the absolute value of A is less than B, then that means that A falls between negative B and positive B. And if you had the absolute value of A is greater than B, then you have A is going to be greater than B, or A is less than negative B. We use these to represent solution sets, and in calculus we do a lot of stuff of applying the derivatives. When we apply the derivatives, then we use our set notation, and when we use set notation or we use interval notation, we have to apply some solution sets. So let's look at how you would do one of these questions and represent the solution. So let's say we had something like, sorry, I'm looking for my example here. The absolute value of 2x minus 7 is greater than 3. If the absolute value of 2x minus 7 is greater than 3, then what ends up happening is that we're taking a look at, we have to write this as an OR statement. So it's 2x minus 7 is greater than 3, or 2x minus 7 is less than negative 3. At that point, we would add 7 over and then divide by 2. So on this side, we'd have x is greater than 5. And on this side over here, we'd have x is less than 2. If you were to look at this on a number line, greater than 5 over here, open circle, color to the outside. 2 right here, open circle again because it's not equal to, color to the outside. We don't do number lines a lot, but we will look at some sign lines in just a little bit. The way we represent this solution in calculus is we would use parentheses. So I'd say it's from negative infinity over to 2, and I'd use parentheses, which is what we call an open set because it's not inclusive of the 2, union with parentheses 5 to infinity. I'll define for you the parentheses and the brackets here in just a moment, but that's the way it would look. And again, solving the absolute value statement is not all that important in calculus, but representing the solution is. When we represent solutions in calculus, we take a look at interval notation. And with our interval notation, this is very important. We have parentheses. It's x value to x value, lower to upper. And this is called an open interval. If we have bracket x value to x value, that's called a closed interval. And then if you have a bracket and then a parenthesis, which you can have, this is called half open. In my previous example, I had an open interval. Let's look at one with a closed interval. This would be like an equal to statement. So we'd have something like the absolute value of 3x minus 1 is less than or equal to 8. In this one, we can write it as a compound inequality, so we can write it as 8 is less than or equal to 3x minus 1. It's less than or equal to 8. If we add 1 to both sides and then we divide by 3, we get x to fall between negative 7/3 is less than or equal to x, which is less than or equal to 3. On my number line, remember, there's negative 7/3, there's positive 3. I have closed in circles at both places, and then I'm colored in on the interior. If I represented an interval notation, it would be from negative 7/3 to 3, and I use my brackets because it's inclusive. A couple of other things that you should be familiar with in going on this first part in this algebra review. We take a look at equations of lines often, and many times it's easiest if we use point-slope form of the line. Point-slope form of the line, if you have a slope of m and you have a point of x and x1 and y1, point-slope form of the line is y minus y1 equals m times x minus x1. That's an important equation. Now we can start there and we can manipulate it around into other forms if we would like to. But that's an important thing to understand. So if I had something like, I want to write the equation of a line that goes through the point, let's say 2, 3, and has a slope of 1/2, then it would be y minus 3 equals 1/2 times x minus 2. If I were to also, if I sometimes look at different types of functions, and we have even functions, and in even functions, if you have f of negative x, and that's going to equal f of x, and then odd functions is f of negative x equals negative f of x. One other concept, and that's just slopes of lines. In terms of slope, we look at slopes of lines a lot in this first semester because we talk about the derivative, which is the driving force of calculus, and we take a look at the instantaneous rate of change, which is the slope of the line tangent to the graph, which we'll get into later on. But in terms of just slopes, you should know that a vertical line, that vertical line has no slope or an undefined slope. Horizontal lines have 0 slope. And it's important for you to know those things because we take a look at the tangent lines. Excuse me. You take a look at tangent lines, and we want to know when's the tangent going to be a no slope or a vertical tangent line or a horizontal tangent line. So you do need to know that stuff. That's about it for this first part. There will be some factoring when you take a look at factoring problems or problems with quadratic problems that require factoring. That will be without a calculator. If you have a calculator, you're always welcome to graph it and just calculate the zeros. But besides that, you should have enough information to do the first assignment. There are a lot of things there I didn't cover, like equations of circles, that kind of stuff. But if you have questions, you can ask me in class. I didn't, this review is just this. It's a review. When we start getting into calculus, I'll teach more fully. But for this first part, this is just review. I just touched on a few points that are very important.